So thank you guys for joining us today. We're going to go over a little bit about drop control and kind of what we do. In case anyone who's new here that doesn't really know what WiseCon does, then we'll leave it over to Brian with FarmitRX, and he's going to basically take over and show you everything that he and his company are working on. Right now, Mark Yoshimoto is our Central Valley sales manager. He's going to go over this PowerPoint, and he's going to kind of show you the ins and outs of WiseCon, a very basic overview. Mark, you can take it over. All right. You can click on it first.
What do you click?
Just anywhere.
Morning, everyone. Thank you for joining us today. Like Daryl said, my name is Mark Yoshimoto. Briefly talk about our company, WiseCon. We were founded in 2006 in Villa del Mar, Chile. Opened an office here 5 years ago, back in 2015. We currently have over 200,000 acres deployed in automation and telemetry, ranging about 6,500 nodes out in the field. We have 20 different distributors here in the United States, and 15 of them are here in California. There's over 1,000 users in 5 different countries here in the United States, Chile, Mexico, Argentina, and Peru. And we have a local support team and warehouse here in Fresno. Give us a call. We have 1-800 number. We're happy to help you if you guys have any technical questions or just want to chat, go over our platform. We also have an open API. We integrate with other software companies as well. So if you're currently working with Phytech, Montage for Ag, there's a ton of others. We can push and pull data for you. So WiseCon, we deploy a system called DropControl. It's a reliable irrigation and monitoring control system. It's able to connect to any sensor, operate wireless valves, pumps, and injection systems. They're an easy to use online platform. On the left-hand side, brief overview, starting at like a pump station, starting and stopping a pump, going to a reservoir. We can pull from a reservoir as well as do reservoir fills. Out in the field, like I said, we're agnostic on our sensors. So we can read anything from transducers to read pressure, flow meters, soil moisture sensors, gathering ET based off weather stations, dendrometers. Sky's the limit. Here's a typical filter station you usually see in the valley. Starting off, our bread and butter is pump starts. Starting and stopping any pump, regular well, booster, chemigation, fertigation, and acid. Then we'll read your flow meter that's currently hooked up. Mag meters, AG 3000s, doesn't really matter. Reading pressure before and after the filter to get a differential. Reservoir level control. You can do this manually through our platform, or it can be autonomous based off a level switch. Filter flushing, we're soon to get into at the moment. Groundwater level, so we can read ultrasonic transducers or a level transducer that'll go down your well. And we can also do an overall pump efficiency test for every block.
You can use arrows now. That should work. Yeah, you can.
There you go. Yep. Quick picture. This is just a regular valve out in the field. This is a hydraulic valve. Most irrigation companies are going towards these on new installs. It's what we hook up to. This is a 12-volt DC latching solenoid that we tie into. If your valves are at the filter stations and they're in clusters, we can run 24-volt AC as well. We also have the option to give the grower valve operation feedback. So we'll tie in a transducer or a pressure switch downstream of the valve. So quick notification that, hey, the valve did kick on or it did open or close. Talking about drop control. Drop control is a 2-part system. We have our hardware and we have our software. Our hardware consists of 3 different variances. We have the C1, which is the ultimate filter station controller. Briefly, it has 10 inputs and 10 outputs. So if you had, as an example, maybe 4 filter stations next to each other with 4 boosters, couple chem pumps, flow meters on all 4 boosters, FERT meters on all your chem pumps, this would technically do it all. Also has Bluetooth capabilities where you can walk up to it and do everything in manual mode if you would like. The X1, this is our flagship node at the moment. It's a controller and a data logger. And then we have the M1. The M1 is going to be a little more economical. It is a data logger only, so it does not have any controllable capabilities, but it'll read any sensor in the field. Briefly get into the X1. The X1, like I said, it's a data logger and a controller. So it will start and stop pumps, open and close valves, read your soil moisture, read your weather stations, anything in the field. All of our nodes consist of a 900 megahertz mesh radio network. It's an open airwave. We run off an expansion board technology. That's pretty much plug and play. Like I said, we are sensor agnostic. As long as the sensor that you have is an open protocol, that's pretty much off the shelf. We do require 1 gateway per ranch. This gateway is pretty much the same thing as a regular X1 node. It just has a cell modem or Ethernet modem on it. That's how we ping all the data from the field to the cloud. We also include an 8 gig SD card in the node. So if anything does happen, AT&T cell tower goes down or something like that, we're always retrieving the data. Once it goes back online, all that data gets sent back to the cloud. Each node is self-propelled. We include a solar panel and a lithium-ion battery. Talking about expansion boards, pretty plug and play. It's like a Lego. The X1 node has 5 different slots, so you can adapt 5 different expansion boards per node. We have expansion boards such as pump relays that start and stop pumps, 12-volt DC latching for your DC latching solenoids. We read 4 to 20 for pressure transducers, dry contacts, SDI-12s for most common soil moisture sensors, and RS-232 and 485. Like I said, these are some of the accessories that we adapt to. Weather stations, Davis, Campbell Scientific, Pestle. We do give each grower a local CIMIS weather station. It's included, it's free. That's ran through an API. Tie into soil moisture sensors. You have Centec, HSTI, EnviroPro, Decagon. We can read pretty much anything you'd like. If you currently have an existing system or older sensors in the field, most likely we can tie into them. Flow meters, pH and EC readings, ground level water monitoring, so well depth cables, pump control and runtime. We can also tie into your VFD, kick it on and off. We look into dendrometers. We can do fertigation pumps, proportional fertigation, reading pressure transducers and switches, get pressure differentials, and then opening and closing valves throughout the field.
That's pretty much
it. In software?
Yeah, now we're basically just going to give it over to Brian, but with our software, it's pretty much the desktop version and the app. You can access DropControl on your smartphone, on a tablet, or through your desk at the office.
All right. Hi, everyone. My name is Brian Bassett, and I am the CEO and lead agronomist at FarmitRX. FarmitRX is a multi-tiered company. We have multiple services, and then we are a WiseCon hardware reseller and service provider. There are several things that we do uniquely different from other sensor technology companies who are providing the retail sales on this. We have integrated multiple forms of ag tech technologies in order to accomplish a higher return on investment in a shorter period of time. What we have found is that as we remove various pieces of ag technology from the overall program that it extends the ROI and reduces the actual amount of return over that time. But by combining all that information, we're able to achieve much higher outcomes, better outcomes for the client. So the first thing is that we have what we call the water optimization process, a 5-phase process that we call the H2O Optimizer. This is something that I actually started 30 years ago. My background is I was raised on a farm, did all the worked for my father, plant science major, and then got into research working for the University of California. And one of the things that became very apparent to me early in my career was that soil variability determined all of the various differences that we find out in the field, from disease to yield, quality, even pest pressure in some cases. We're all related back to these various differences. And for me, about 28 years ago, I purchased my first geophysical soil mapping device. And so that's where the H2O Optimizer process basically started. So it's a 5-phase process. And the reason why we think that and have gotten such good results with our clients and in the majority of the projects that we're involved with is because of a simple fact, which is, how do you place a sensor in a field when you do not understand the variability that exists in that field and how that variability is differentiating itself as you cross the field? So where do you stick a sensor? And this goes for any type of sensor that you use. Now, we happen to use volumetric soil moisture sensors. And so therefore, that's our focus. But if you're using a Phytech sensor or any other type of sensing device, where you place it in the field determines really the validity of the information coming back. In other words, does it represent the variability in the field? So as the beginning portion of our process, we take and collect 2 data sets. One is a geophysical soil map, and we do that by traversing the field using a gator and a sled, and it's basically collecting geophysical information. And then we combine that data set with a series of multispectral images. Now, the images can be of a current existing crop, or it can be something that was pulled from previous historic crops. But one of the things that, you know, as a ag tech person and have said originally in the beginning of the presentation, that we utilize data, all forms of ag tech data. Imaging is one part of it. Unfortunately, in our industry, imagery is used in a lot of cases incorrectly, and therefore the outcomes for the growers are, they don't have a good value. So what we do is we've identified multiple uses for imagery, and one of them is to combine them with a geophysical soil map to determine what we call what is variability, and create what we call a variability map. Now, that variability map is then utilized for the purposes of sampling, and we have 2 phases of sampling. The first phase, phase 2, is where we collect for general fertility purposes a 0 to 18-inch sample. And then, as you can see, what we're doing is we're trying to represent fertility and soil variability, both from the original phase 1 maps, but then also through phase 2. We then help growers determine, based on this phase 2 sampling through lab analysis, what is the correct amount of fertilizer and amending to do to the various areas of this field. If there's enough of an economic difference in the field and it justifies a variable rate application, we will help that grower to get the application of fertilizer based on a varied rate. Now, that requires some additional companies who have the application equipment, but we work with those companies to get that project done. Phase 3 is the phase where we do deep coring, and we're looking at typically 0 to 6 foot, but we've gone as deep as 15 foot when it came to looking for perched water tables. The information that we collect from that is then again submitted to the lab, and we do particle size analysis, we look at infiltration rates, and we do a salinity chemistry analysis. So this is different than phase 2, where we're looking at full fertility cations and all of the various constituents that we can analyze for. This is a more focused analysis, and there are a lot more samples pulled, in this case, a sample every foot after the 18 inches, so that we can fully characterize the soil down to 6 foot. Think of it in effect as creating an MRI. Now, what we typically find is that although you can see in this surface representation from 0 to 18 inches, this is representing particle size analysis. And the particle size analysis for this field showed that we had a sand streak, we had some heavier clay soils, and then we had a clay loam soil. As we move down to the soil profile, when we look at the sand streak got progressively heavier. As we looked at the clay loam area on the surface, the clay loam area at about 3 foot got progressively lighter. Now you can imagine if you were to randomly place a sensor in this field, how the outcomes or the information provided by that sensor would be unreliable, not match the conditions that the client sees in the field or the manager is seeing in real time in the field, and therefore is not scalable as far as utilizing sensor technologies across a larger portion of a grower's ranch. And so what we typically find is we meet clients who currently have soil moisture sensors. We just completed a 1,300 acre project, 5 different ranches. And in that project, they had 16 soil moisture sensors spread out across these ranches. We relocated all but one of the sensors. They were not representing variability in the field, and the client had abandoned them, as most of the people that we know that we meet who have purchased technology and randomly place it. So through our 3-phase process, we were able to help the grower to understand what variability existed in the field, and then where we could put sensors in the field to accurately represent that variability, and then provide them with the information that they need to schedule an irrigation. Phase 4 of the process is where we will then recommend irrigation design layouts, project modifications to an existing system, and depending upon whether it's an open field or it's something that's already been planted, we'll utilize the existing system and break it up into blocks based off of what the grower has available to them, so that they can manage based on the differences that we identified in the mapping process. There's some more simple ways to do this, where we've got growers who have quarter sections, and we put sensors in the light, heavy, and layered areas. And from that, we're able to schedule an accurate irrigation that maximizes soil plant available water and therefore crop yield and uniformity. It also helps to reduce inputs. So the idea being that if we have an open project where it's a new planting, we can come in and we can design an irrigation system that matches soil variability, we can do that. Now, there are a lot of variables that go into determining whether or not we could do VRI and whether we should. So we look at the economics of it, not just the cost of the system, but is there enough difference in variability to justify an extreme VRI system? And that's what I would call it. Now we can look at the above map, that's the yellow, green, and the red, and that is a form of VRI where we have an existing system and we're addressing water requirement based on the soil and the sensor and the current weather conditions, so that we can optimize the current irrigation system. However, there are cases when we are given the opportunity to work on a new project, and this isn't a fairly extreme case, but I thought would be a good example of how we can take a fairly extreme design where we have over 1 inch per foot of soil difference in water holding capacity. So we're talking about a soil that needs to be irrigated almost every day versus soils that could be irrigated every 3 to 4 days, up to a week. So this is a system that's a variable rate design. It's 226 acres. It's a 2-set system. I know you got a lot of colors going on in there, but think of set 1 as areas 1, 2, and 3 as identified on the map, and set 2 as areas 4, 5, and 6 identified on the map. It makes up 105 and 121 acres. And so the grower is able to irrigate these areas based on those set systems. The irrigation duration, and when we talk VRI, there's multiple ways to achieve VRI. Now, if this was a berry crop and we were really looking for high degrees of accuracy in maintaining soil moisture, we could actually be irrigating this in a 4-hour in the light soils and as much as 24 hours in the heavy soils. However, this is a nut crop and we don't have quite the requirement as far as precision of water, and therefore are able to get away with a little more of a uniform application rate. And in doing so, in this field as an example, our typical duration of irrigation is 12 hours from bloom through nut fill. As we move into the later parts of the season and we're looking at hull split, we reduce to a 6-hour duration to deficit irrigate and help the client to achieve harvest uniformly across a highly variable field. And the irrigation frequency is varied by the requirement through both of those stages. So even though the irrigation duration is 12 hours for the entire block, all areas, one area may get 24 hours for the week and another area may get 36 to 48 hours for that week. So the irrigation frequency is where we come up with a variable rate in this example. Now, again, as I stated, with a more precise requirement, such as a berry crop, we will literally change the duration of irrigation so that we're putting out different durations and frequencies of irrigation. But we're finding more and more, particularly with nut crops, almonds, pistachios, and walnuts, that we're able to achieve optimum performance by simply utilizing this tactic. So, irrigation automation that works for you. We actually got into the automation and sensing game out of frustration. As a consultant, I would spend a good portion of my time contacting sensor companies about systems that were down, were not operating, were not calibrated, and were not functioning properly. And the information that was being provided was inadequate and incorrect. And so I looked at the suite of companies that, quite frankly, you all know are available to us today, and I chose Wisecon. And I chose Wisecon not because they've given me the best margin or not necessarily because of anything other than they have a rock solid platform. They're willing to work with the client to achieve their goals. And they've been very supportive of us in our further development of what we're going to talk to about in a minute called ImScheduler. And so it was a really easy decision for me because of, again, the quality of the equipment and the level of service that I was going to receive from the organization, that I went with Wisecon as an exclusive dealer. The main reason I did that is I just did not want to have to deal with multiple systems. So FarmitRX does equipment sales, system management, and maintenance. So if we're not just a sales company where we come out and we sell you a piece of equipment and then we're gone. What we want to do is help the grower to achieve full return on investment for not only that equipment, but also the system itself. So when we talk about irrigation automation, and quite frankly, Mark did a great job of reviewing what and when and where and how, what we can do with the Wisecon system. But we're focused again on Sentex sensors, Sentex soil moisture sensors. We've got that multi-phase process that we just went through that I gave you examples on. And the purpose of that process is to tell us exactly where to place our sensors and how to design and irrigate the field. Now, the sensor provides real-time feedback as to how we should irrigate. More often than not, what we found is that without automation, growers were unable to achieve proper irrigation frequency and durations, primarily due to labor, fertigation practices, and many other things that limited their ability to properly apply water to the field and maximize their outcomes using that technology. So because of the data we've collected in phases 1 through 4, and the system we designed, the volumetric sensor made the most sense to us. In addition, versus some of the other sensor technologies, which again, we use, but from the standpoint of understanding when to irrigate, they'll all tell you when to start an irrigation. A volumetric sensor will tell you when to shut it off. And so because we don't just maintain the amount of water in the soil, but are actually irrigating to maintain an optimum wetness in the root zone, the volumetric sensor is the best sensor on the market to achieve that goal. So what is ImScheduler? It's a subscription software service. FarmitRX currently has an API with Wisecon, so I suppose we're one of the 5+. And what we've done is we've taken that phase data and we've combined that with the DropControl sensing data and historic CMIS data and various other pieces of information that I'm going to go into in a little more detail here in a second. And we have a platform called ImScheduler. Now, the first thing you're going to notice about ImScheduler is that there are no graphs. Now, we do have a graph function within the software, but I'm not going to show that to you here today. The purpose of our system is to give growers specific targets for their sensor tech in the field and allow them to utilize sensor technologies at scale, meaning this example right here has over 60 soil moisture sensors and 144 valves. It's a 3,100 acre project. Each of the sensors has a camera mounted on each sensor location, and the camera is taking images daily, and we're using that for pattern recognition and will be using some machine learning, but currently are only looking at pattern recognition. The other thing you'll notice is everything's very graphic. So we've got graphic illustrations based on targets. Now, the DropControl system is a very good system and it's very easy to use, but it is time consuming and it does require a certain level of experience to interpret the information and then apply an automated schedule. The purpose of ImScheduler is to provide a graphic illustration of what's going on in the field and then take the grower's targets, available water, irrigation system design, and the multi-phase process that we use to provide a schedule based on the grower's own requirements. So in this case, we've got the main map window where we're showing what the current field capacity is relative to the targets. And as many of you know, during the season, targets change. So our system automatically puts green at whatever the current target is. So if we're at nut fill, we're going to be at a much higher soil moisture field capacity in the field. And when we're at harvest, we're obviously deficit irrigating because we're drying the soil down so that we can get the crop to harvest. Well, our system, green is always on target. So whether we're at harvest or we're in the vegetative phase or we're in the development phase of the fruit or nut, green is always on target. Blue is too wet, greater than 15% above target, and red is too dry, more than 15% below target. In addition, we provide those same target levels, again, because of our phase mapping, for each individual sensor. So as in the example right now, what I'm showing is we have an illustration on the right-hand side here showing the actual percents of field capacity of each depth of the sensor in the soil. And what we're showing in this graphic illustration is on this ranch, there's a couple of locations where we're wet on top and we're starting to lose deep moisture. So again, the purpose of the more illustrative form is so the grower can rapidly look and review where he's at, not only just from the standpoint of how wet are you, but what are you looking like as far as depth of available soil moisture within that field, and are you losing deep moisture as in this example. In addition, we also have pump flow, reservoir flow, fertilizer, all of those things available on the site. And we have multiple reporting functions, and I'll show you a couple of those here in a second. But here's yet another area of the field, another sensor where you can see that the grower is nearly on target across every sensor and therefore on target for the entire block. The other advantage that we are providing is, again, another visual representation of whether or not we're running water. We have real-time weather here from the weather stations that we have connected out in the field. We have 2 weather stations located on this ranch. And so that information is displayed in real time, and then we have a historical way to access that data also. So in general, the purpose, again, of ImSchedulers is for scale. And what do I mean by that? So here's an actual report. If you go to the upper right-hand corner of that screen I just showed you, it has a schedule button, and you hit that button, and basically this is what a report looks like on the web page. Now, this system that I'm showing you right now for a very specific reason is an example of a 3-hour irrigation across every single area. However, it's a pulse irrigation because we have both light soils and layered soils. And so in this instance, a pulse irrigation was the best fit for the field. Now, unfortunately, this is an example again where automation plays a significant role in the grower's ability to achieve the desired outcomes. And the other unfortunate fact is that this type of a schedule, as precise as it is requires someone to, again, analyze. This field has 7 soil moisture sensors. It's a 200-acre block. It's highly variable. And in this 200-acre block, we have a requirement range of 24 to 36 hours. And this is actually the schedule for this last week going into harvest. They're shutting down the nonpareil rows, and the remainder of the Monterey's and Aldrich in this field are going to be getting the 24 to 36 hours. Now, in addition to the fact that we're providing a schedule, we're also providing a report here. And the report down across the bottom lets the grower know whether they're losing deep moisture, if they're too wet. We have a phenology target here, which I'll discuss a little more here in a minute, the current status, and the overall trend of the soil moisture over the last week. We then have what your standard ETO times KC requirement is, and then a requirement when we consider what the soil moisture sensors are telling us. So we're using a forecast model that's based off of forecasted weather to key our ETO, and then our crop coefficients are calculated in real time, and I'll discuss that also in a minute. So this is really great if we have the automation, yes, but the problem comes in again is that somebody has to log in every week and take this schedule and then type it into DropControl to activate the schedule. So what we did is we built the software so that it would automatically place the times for starting and stopping all the various valves, including the pumps, into our system, so that once we provide the schedule based on, again, the phase data, the grower's targets, his available water, and what the sensors are telling us in real time, we then take that schedule and apply it based on, again, the grower's start times, of whether he wants to run on peak or not on peak, if they don't want to run on Sundays. We got that all set into our program, ImScheduler, and then it applies the schedule based on that client's variables. So we take your desired targets, everything from starting times, stop times, days run, times off, irrigation system, all that information we collected in the phase data, and the system will provide you a schedule based on how you would like to apply that water. We can then apply the schedule and then send it to DropControl for automation. So it eliminates any typing in of all these times and days and what sets run together. All that's already been pre-coded. And so we just, once the client accepts the schedule, or if they want, they can edit it literally on the screen. If they decide they don't want to run on the first Monday or the first day, or they don't want to run on a specific night, or they want to change anything about the schedule, they can do that and then apply that schedule and send it for automation. You can obviously print the schedule and then all that too. So what we end up with is our system then takes and stores that information. It stores not only what the target field capacity was and the crop coefficients we used and the actual field capacity, the recommended inches, the applied inches, but then it also stores the irrigated inches. And what we end up with is a database that we can then go back and look at, and the system is actually doing this in real time, and it's editing and adjusting the values and learning based on how you irrigate. So the obvious advantage to this is that if you potentially under or over irrigate, which there are instances within this graph where the grower did that, and they either didn't follow the schedule, they had to fertigate, and therefore they had to apply more water, or whatever the case might have been. But as you can see, based on the blue dots, that the software is simply trying to maintain and achieve specific targets and levels. So it's adjusting based on the real-time weather that's forecasted, and the crop coefficient is being adjusted based on the differences coming back from the recommended hours versus the applied hours and the differences in between. In addition, and this is all provided on Wisecon system, but we also provide pump monitoring in real time so that we can determine, in our case, what we're looking for in this instance is rate of change of flow, of which you can see there's very little change in flow. Now, most growers use flow meters, but the purpose of our system is to provide information as to whether or not you're going to have problems with this well, and before it goes bad on you, that you're able to address that issue. Now we're seeing in this well, we're getting lower and lower drawdowns as we're going through the season. And so this is something where the drawdown is significantly changed and has changed since the beginning of the year, and something that the growers needs to be aware of, because they're actually considering drilling some more wells out here. And I think that based off of this information, that we're going to have some other type of remedy to deal with what we need to deal with. So the long and short of it is that ImScheduler is a software as a service, and it provides a daily, it's actually updated every 15 minutes, but it's updated schedule through imscheduler.com. And this eliminates the need to rely on any one individual, but rather validated data analytics, resulting in a recommendation from software utilizing AI and pattern recognition. Now, the results are pretty obvious as to how and why we would get those results. I've briefly explained some of the ways that we achieve that. But the biggest thing that we've identified is that really what we do beyond improving yield and quality, and that's obviously good, but it's really longevity of the orchard or vineyard. What we have found is that every time we irrigate incorrectly, or we get a little too stressed, or we get the soil a little too saturated, that we are impacting negatively the longevity of this investment, of this orchard. So the first year we do a couple irrigations where we're not quite getting it right, or we get a little dry, or we get a little overly wet, maybe not so bad of an outcome. Maybe that year it's fine. But as we see over time that as we have these periods of stress, that compounds the decline of the orchard or vineyard. And so, although again, we obviously want to reduce our applied water, which I'm going to show you here, and I actually should go back. Let's do that, because let's look at reduced applied water. This is going to be a little hard to believe, but this is real-time data and it's up to date. Okay, so this is a field that's going to be harvested, and we've only applied, it's going to be harvested in 10 days, and we've applied on average 20 inches of water. So it's a fifth, 6-year almond crop. Yields are wonderful, they're fantastic. They're going to be in the high 3s, 4s, low 4s. And we've done 21 inches in one area, but the average is 20 inches of water. So when we talk about saving water, we're talking about significant water savings, not just small water savings. So, but the other side of it is, and again, I want to get back to and reinforce this strongly, is that longevity of investment is what we're talking about here. And so when we're talking about a system, because there's a capital cost involved with both the phase mapping and obviously the hardware and the ongoing services. But when you look at the cost over the longevity of the investment, you're talking about somewhere between $15 and $30 an acre. Now, for $15 and $30 an acre, I think that's a pretty low cost to pay to reduce water, improve quality, improve yield, improve labor productivity, and take a 20-year orchard and extend it to 30 years, which is something we have literally done. So it definitely has multiple beneficial outcomes. Now, what's really unique about ImScheduler is that we are doing what everybody else is still doing with a pencil and a piece of paper or maybe an Excel sheet. So we use ETO from forecasted weather models. I briefly explained we have real-time crop coefficients by soil profile and variability. So these aren't the same across field to field, and they're not even the same within a field. Crop coefficients vary by soil profile. So depending on your soil types and your textures, your crop coefficient is going to vary. Obviously, the size of the trees and vines are varying. We have an ETC customizable irrigation template, so we can put out any configuration of water and irrigation based on the grower's needs and his timelines and ability to apply that water. We have phenology-based field capacity targets, and everything's run by growing degree days. So we're able to repeat and duplicate the same outcomes year after year. The irrigation schedules are updated multiple times daily. Approved irrigation schedules are uploaded to DropControl for automation. We do water source count balancing and fertigation management. The last portion, and I mentioned this in the beginning of the presentation, is that we have a phase 5. And I mentioned that imagery, in just like a pressure bomb, which we use to help calibrate our soil moisture sensors, we use the pressure bomb in combination with the imagery to do a sensor calibration or audit, what we call. And so we consider our phase 5 is imagery in the report card. And we utilize multispectral imaging, real-time data, to do everything from sensor calibration, identify distribution uniformity issues, and rate of change. In other words, we take pictures of the field at various dates that are the same from year to year, and then we can do analysis of those images and to see if we have increased distribution uniformity issues, and as a perfect example. So again, I think that the one thing that we've learned and that we have really come a long ways in understanding is that the value of these technologies are in the integration of these technologies, and that if we want growers to use them at scale, that we need to provide them with the platforms in order to still do their job, but use the technology. And that's what ImScheduler does. So we combine that with the soil mapping and the imagery, the pressure bombs and the various other information, and allows us to help the grower to achieve greater outcomes with a higher degree of satisfaction, and ultimately to the benefit of the client. Any questions?
Perfect. That was great, Brian. Thank you for that. So yeah, right now, everybody, if you can, there's a Q&A at the bottom. Go ahead and throw in your questions there, and we'll be happy to answer them. I know right now I'll kind of go into a little Q&A myself with Brian, so we'll kind of go over some stuff that we had prepared. All right, so what were your prior experiences with other ag technologies, like in terms of maybe hardware or different soil probes or different automation than you use now? What were some of the issues you might have seen or problems in the market that you saw?
The biggest one was that most, and again, this is part of our holistic approach to the technologies, to ag tech, is that we have so many companies that are doing bits and pieces of this work. And again, it comes back to what I said multiple times during the presentation. You know, Phytech's got a sensor, and the sensor works. If it's properly located in a field, it's a great technology. If you know why you put it where it is, then you're going to have an expectation as to its outcome. But what we found was that if you can't respond to that, so I've already, in answering your question, brought up the fact that by using the mapping process, you're able to properly locate the sensor. But then how do you properly irrigate or respond to that sensor, whether it's a Phytech sensor or a Centech sensor? And so what WiseCon has allowed me to do is to integrate the automation component, the fertigation component, the monitoring of the hardware within the field, so that I'm talking pumps and wells and reservoirs and all of these other pieces of equipment. And it's helping me to, again, provide a better outcome for the client. So, and higher ROI, faster ROI. So that to me is the biggest issue with ag tech, period, is that we have all these we got image companies, we got sensor companies, we've got, you know, all these various technologies, and unfortunately they're not working together. And so that's the thing that WiseCon kind of completed my packet, right? Or my linear business model, my vertically integrated business model, where I wanted to be able to start with a mapping, provide the hardware, and then provide the software that actually helped the client to utilize that hardware. And so that to me was huge.
Gotcha. And like how you said before, it's not, you know, you're not a salesman, you're just going to sell a product and leave. How often are you guys usually in the field, either with the grower or giving them recommendations, installing equipment?
Well, we've really focused in our organization on making sure that our installations are extremely robust. And so repair wise, we don't actually have to spend a tremendous amount of time doing a lot of repairs. There are three things that cause problems in the field with this technology. The first one is water damage. Okay, water is a killer. So if you don't have your equipment properly sealed, water is going to take you down. The second thing is what we refer to as tractor blight. Now, tractor blight, I can't do anything about. When somebody runs the equipment over with a piece of equipment, you know, we're going to have to go out there and make a repair.
Yeah.
The third one, in which we've actually eliminated, is animal damage. That's something that is a real problem, and there's certain fields where, I mean, they're not damaging our equipment, but they're doing a lot of damage to the irrigation system itself. So we've come up with an installation that literally eliminates animal damage. So for us, once we do the installation, the reason we go back to the field is because we had an expectation when we put the sensors in those locations. If the sensor does not accurately reflect the soil moisture in that field, we will know because it'll be out of range. So what we do is we have certified crop advisors that on Monday morning sit down and go through all of ImScheduler, every single sensor. And that bases the foundation for what is that man going to do that week. Determines where he's going to go, what he needs to repair, what sensors he needs to do a calibration and audit on. And the calibration and audits, you know, it would be very complicated if we had to go to every single sensor every week, right?
Yeah.
But because we have an expectation from each sensor, we're able to determine what sensors are actually out of range and need to be addressed, and then therefore focus on that series of sensors. So we may go to a field and there may be 4 or 5 sensors on the ranch, but we only go to one of the locations because we're dealing with one sensor that's out of range. Now, what creates an out of range sensor? You'll have anything from one of the actual volumetric sensors going down themselves, a plugged emitter, a leak, somebody moved the drip line, somebody moved the sprinkler. But ImScheduler has all these measurements in it. So when we go out there, we look to see, okay, well, the sensor previously was this far from the emitter and this far from the tree, and now something's changed. Well, now we know what to adjust, because again, it's all part of ImScheduler. So that would be how I would address that. Ours is based on the need or requirement to go to the field. And we find that with the equipment, as long as, again, water, killer.
Yeah.
I've stubbed my toe on water, okay? And we've had to really come up with some inventive ideas on how to address and deal with water in the field. And we've done that with WiseCon.
Gotcha. Perfect. For FarmitRX and our ImScheduler, is it taking into account the emitter type, like if it's subsurface drip, double line drip, or?
You account everything about the irrigation system, the planting, the spacing, all of that information is critical. Pump flows. As an example, if a certain area of the field has a higher degree of stress, ImScheduler is going to focus water to that location and then follow up irrigation in the other areas. So when I said water balancing, what we're talking about is literally we have a lot of growers that are short on water. And what we do is help them to allocate that resource more efficiently. So instead of them having to figure out where do I put the water based on the sensor reading, ImScheduler is doing that for them. So yeah, the only time that ImScheduler is wrong is when we put the wrong variables in. So in other words, specifically to your question, if you tell me that you have a 0.05 application rate and it's a 0.04 application rate, well, ImScheduler is wrong, because it's basically doing the scheduling based on understanding what your actual application rate for that system is. If you tell me that you're doing 1,000 gallons per minute, but you're only doing 800, well, ImScheduler is going to be wrong, because if it does not have the accurate volume of water that's being applied, it's going to try to get you to irrigate in a way that you shouldn't be or can't irrigate.
Gotcha. And for ImScheduler, the service, is there any type of minimum acreage that they have to have, or any type of crop requirements that you guys have for them?
No, because again, here's the way I look at it. I never show up on a grower's ranch and think that I know more than the client. That client has a tremendous amount of experience with that crop in that field. So they have all the information that I don't have, that ImScheduler needs to successfully provide them with a schedule. So, you know, we work closely with the client on all crops, all field sizes is not really relevant to us. What we're focused on, again, is greater adoption of the technology. And not just because we want to sell hardware, but because we believe in what we're doing.
Gotcha. Yeah, I think that's a big trend too, is a lot of some ag tech companies say, oh, we're the brain of the operation. Whereas here and with you guys, it's more the grower's the brain, but
Right.
we're just providing the tools to make it more efficient and have them
Right.
apply water.
I'm ag tech. I want the clients that work with us to not see ag technology as a burden. And unfortunately, currently, the way it's designed, and this is no slam on WiseCon, this is how all ag tech is designed their technology. It's more work. So what we're trying to do is to bring this product to the client and say, well, we can actually make your life easier with this product.
Mm-hmm. Yeah, definitely having a hand in the process is helpful to the grower. You can't just slam it in front of their face and say, okay, here you go.
Right.
All right. I think that's pretty much it. That's all we've got right now. Anything else you wanted to say before we head out of here?
I appreciate the opportunity. If anybody has any additional questions or information, I'm sure you can make my information available to whoever wants it.
Oh, of course.
We'll be happy to work with any kind of grower, any size. That's, again, not really an issue. Just feel free to give us a call or hit me on my email. We go to www.FarmitRX.com, and I believe my email contact is right at the bottom of the page.
All right. Thanks, Brian.
Thanks, Daryl.